So for chlorine, we'll leave that. And argon still does not react. Okay, so these are our reactions with chlorine. And one thing more, that you should also know the structure, bonding structure of this S2Cl2. So you have, I think, a single bond in between them, and you have these bonds like this. Okay, so there's basically single bonds. Then we have yeah, sulfur chloride. Yeah, because I did saw in one of the past paper question that you should know the bonding and structure of each and every compound. It could come in, and like first they ask you about, question starts with the periodicity, and then if it moves to the bonding and structure, okay, it happens in, if you see the structured questions, they do ask about the bonding and structure, draw the dot and cross diagram of this compound and so on. Okay, so you should know the idea that what is the bonding, whether it has single bond or double bonding in between them. Then we have reactions with water. Reactions So reactions with water, we will be having sodium. Okay, sodium will react very vigorously. Okay, very vigorously with water. That much vigorously that it catches fire, and in cold water. Okay, even if I have used cold water, it is that much reactive that it will catch fire. Okay, and it is a very violent exothermic reaction, and it forms sodium hydroxide and hydrogen gas. So sodium catches fire in cold water and a violently exothermic reaction occurs to form NaOH and H2 gas. Equation is quite simple. You have Na solid, then sorry, O2 I have written H2O, NaOH and H2 gas. This will be the aqueous solution, and if we balance it out, okay, now it's balanced. Now for the magnesium, It reacts very slowly with cold water. Okay, like several days. That much so that takes several days to collect, a test tube of hydrogen, because it will again form a hydrogen gas and a very weak alkaline MgOH solution. But it reacts rapidly with, steam to produce MgO, okay, and hydrogen gas. So in which we have two scenarios, like you have cold water reacts very slowly, takes several days, and form weak alkaline solution. Mg solid plus H2O liquid to form MgOH and H2. So it forms a very weakly alkaline solution. But with hot water, or you can say steam, reacts rapidly, forming not MgOH, now it forms MgO, because you are directly reacting it with steam. So now H2O will be what? Gas, okay, not liquid. Okay, is it clear? Then moving on to now have period 3 oxides and period 3 chlorides. Okay. So now we have the next topic, that is period 3, because this whole chapter has a lot of equations and reactions, so you have to memorize each and every of them conceptually. Period 3 oxides. Okay, so first we look into a little bit of table that gives us a summary of the properties of period 3 oxides that we have recently formed in our reactions. Okay, so we have the structure of them, melting point, acid base nature, and effect of water that we will be seeing in our new reactions. So we have all these oxides that we have recently formed, and these three will be ionic, okay, because there is a metal and a non-metal. And Al2O3 is ionic with covalent character. Okay, it is ionic but with a covalent character, which means that it has some of the covalent properties as well. And SiO2 is, giant covalent. These are covalent but simple molecular. Melting point, if they are ionic, then high melting point, strong ionic bonds. SiO2 also high melting point because strong covalent bonds. And these are simple, so low, only weak dipole dipole, or we call it what, weak van der Waals forces that needs to be broken. Acid base nature, the first two are basic, then this is amphoteric, this is inert, okay, and or you can say neutral as well, does not react with acid or base either, and these are acidic in nature. Effect of water on oxide, okay, that we will be looking, that it forms an alkaline solution, it dissolves slightly, these are insoluble, and these are strongly acidic solution. Okay, so the properties are clear. First, reactions with water. So for the reaction with water, again first NO2, Na2O, sodium oxide, react exothermically. Okay, it reacts with cold water vigorously, or you can say violently or rapidly, and strong alkaline solution of NaOH is formed. Strongly alkaline solution. Oh, sorry, there will be no hydrogen gas because all the hydroxide ions will be consumed, and again it will form the water, but we won't be writing that. Okay, the pH, now the pH of the solution will increase to 13. Then MgO, MgO reacts very slightly, okay, very little bit reaction with water, okay, to the extent that it is, almost insoluble, and a weak alkaline solution, because not all MgO will react with the water. weakly alkaline solution. Okay, I don't think so there's need of any balancing. Okay, so the pH will be not that much alkaline, so it will be 9. Okay. Aluminium does not react. Aluminium oxide, because it has a giant high lattice energy, so it won't break down into the ions. That is why. SiO2. Strong covalent bonds. These two do not react. Phosphorus oxides react to form acidic solutions like pH 2. So first is P4O6 solid, H2O reacts to form H3PO3. This is a phosphorus acid. So the balancing will be 6 here, 4 here. Then say, okay, so this is phosphorus acid. Second, P4O10, sorry, it's not 6, reacts to form phosphoric acid, H3PO4 now. We'll balance it. I think again this will be 6 and 4. And this is now phosphoric phosphoric 5 acid. Okay, is it clear? Then we have sulfur. So sulfur also reacts to form acidic solutions, like they will be having pH 2 again, okay, because these are acidic solutions, and these will be happening. Let me just here. Okay. So again, you have two cases. Sulfur dioxide reacts, okay, and either sulfur trioxide. So if sulfur dioxide reacts with water, it will form sulfuric 4, or we say sulfurous acid, H2SO3, sulfurous acid. And if sulfur trioxide reacts, it will form H2SO4, that is sulfuric acid. That is the difference. Okay, then these are all the oxides that and their reactions when they will react with the water. Okay, now we have the acid base behavior of period 3 oxides, and that is really important. Acid base behavior of period 3 oxides. So we know that the trend that was going across the period 3, nature of oxides was changing from first it was basic, then it changed to amphoteric, and then it reaches to acidic. So we can see that acidity of oxides is increasing across the period. Okay, so across period 3, acidity of oxides is increasing, like first we had basic, amphoteric, and then we had acidic. So in basic we had Na2O and MgO, then in amphoteric we had Al2O3, then in acidic we had P4O6, P4O10, SO2 or SO3. These were the trends. So as we are moving down, the acidity of oxides is increasing across the period. So if we look into some reactions, okay, for sodium and magnesium, first we'll look into I would just write basic oxides. So their reactions will be quite simple. Like you have Na2O and you have MgO. Both will react with, because they are basic, so they will react with an acid. For example, if we take HCl, so NaCl and H2O is formed. So this solid aqueous solid, sorry, aqueous, we can say it aqueous, and this is water. So this is a neutralization reaction. Then from MgO, same concept will be applied. MgCl2 and water again. Okay, so this is the whole concept for the basic oxides. They will just do the neutralization reaction. But now for the amphoteric oxide, amphoteric, that react with both basic and acidic. Okay, both base and acids. So for amphoteric, we have aluminium oxide. So react first, I will react it with an acid. So if I am reacting with an acid, it will be acting as a base. This will form salt and water. Salt will be aluminium chloride and you have water. Simple as that. Now you just have to balance it. Is 6 to 3. Okay, then for the reaction, if we react it with an base, now it will act as an acid. So base means you can say NaOH. Now it will form sodium aluminate, that is NaAl and OH4. This will be the compound that will be formed. Okay, and one more thing, we will be adding water here. Solid, aqueous, liquid. This is an aqueous solution and we call it okay. So we have taken hot and concentrated NaOH. Okay, and to form sodium aluminate, we have to take more water. So first, it will uh, try to dissolve, okay, aluminium oxide and react, because we need the hydroxide ions. So for that, to get excess hydroxide ions, we have added water here. Okay, because not only the NaOH cannot form this sodium aluminate. Okay, so we need more hydroxide ions. Two, then you have three, then you have two. Clear? So these two equations are uh, important for aluminium oxide. Okay, then you have silicon dioxide. So coming to the acidic oxides. But first we should silicon. Silicon, and then we have phosphorus and sulfur. Okay. Silicon, for the silicon we have first silicon dioxide. So silicon dioxide is a, I would say, weakly acidic oxide. Weakly acidic. It is acidic but very weak. Okay, so it reacts with, we need hot and concentrated bases for it to react. Okay, so we will be taking NaOH, hot concentrated NaOH, SiO2 reacts with NaOH to form, now it will form a sodium silicate, Na2SiO3 and water. This will be aqueous and this is solid. This is sodium silicate. This will be formed. For the phosphorus, phosphorus oxides, we have P4O6, it will again react with NaOH because it is an acidic oxide, so it will react with a base to form Na3PO3. Okay, and that is sodium phosphate 3. Okay, sodium phosphate 3, and with it it will form water. So basically neutralization is okay, you have a salt and water that is being formed here. And for the balancing, it will be 12, then you have 4, then you have 6. It's better to memorize the balancing because in paper you won't be having any much more extra time to balance these equations. Okay, so if you should practice them enough so that you remember the balancings as well. It will save a lot of time while solving the questions. Then for the P4O10, just a slightly changed equation. Na3PO4 and water, and the balancing will be same. Okay, that is a plus point here, that balancing is same. Clear? And for the sulfur oxides, we again have a similar pattern here. For the sulfur oxide, we have SO2 first. SO2 will react with again NaOH to form sodium sulfate, that will be of 4 oxidation number. Na2SO3, and along with that you have water again. Okay, so this is gas, aqueous liquid. And for balancing, you just have to balance here. Sodium sulfate 4. So which means 4 is the oxidation state of sulfur in this compound. SO3 is then quite simple, that NaOH, it forms Na2SO4 and water. Okay, now this is sodium sulfate 6, and for balancing again you just have to put a 2 here. Now the equation will be balanced. Sodium sulfate 6. Okay, I hope the reactions are now cleared. So we have studied the acid-base behavior of period 3 oxide, that how they react with either bases or acids, or both, based on their nature. Okay, one last topic to discuss of this chapter is period 3 chlorides and their reactions with water. Period 3 chlorides So for period 3 chlorides, you have again one table to first analyze the properties of period 3 chlorides. So for the structure, NaCl and MgCl2 are giant ionic, okay? They have the crystal lattice structure, 3D lattice structure, and strong ionic bonds, okay, electrostatic forces. Then AlCl3, SiCl4, and PCl3 and 5 are simple molecular, and they, small distance, weak van der Waals forces, they are simple molecular. Melting point, obviously giant ionic, so they will be having high melting point. Simple molecular, so it sublimes at 180, okay, which we study that it is, Al2Cl6. Then SiCl4 and PCl3 and 5 have low melting point due to weak van der Waals forces. Exception, here it is also written PCl5 is a solid. Effect of water that we'll see now, that is dissolved readily, okay. Neutral, it forms a neutral solution, this forms a slightly acidic, and these three hydrolyze to give fumes of HCl gas. Hydrolyze means to break break the compound with the help of water. So these compounds will be broken down with the help of water, so they hydrolyze to give fumes of HCl gas. This forms a less acidic solution. These two forms more acidic solutions. Okay, so reactions with water. First is again NaCl. NaCl just react with water and it just dissolve in water to form neutral solution. So the equation will be something like this: NaCl solid, you add it to water, which means aqueous. It forms, either you can add NaCl aqueous or you can write like this, that it forms the aqueous ions. Clear? And okay, so for the MgCl2, MgCl2 dissolves in water with slight hydrolysis to form a solution of magnesium chloride. Forms slight with slight hydrolysis. Okay, for this you have the reaction like this: MgCl2 solid, then you have water, to form Mg H2O 6 bracket 2 plus, and along with that you have Cl minus. So what we have made here, that it is a complex ion. Okay, what is a complex ion? That is joined by multiple molecules, water molecules, and we will study till now you just have to practice the equation. No need to go into detail because that will be covered in the A2. In A2 we study the complex ions and how they are formed. Okay, what is the concept behind them. Okay, so this is a central species, that is Mg, and it is surrounded by 6 H2O. We called it ligands. Okay, so H2O are basically a ligands. That is how a complex ion is formed. So I'll just balance it out. 6 will be placed here and 2 will be here. Then you have aluminium chloride. Aluminium chloride, it does hydrolyze in water. To give acidic solution, and along with that white fumes of HCl gas are formed. So you have something like this: AlCl3 reacts with water. Again it forms a complex ion H2O, and it is 6 3 plus, and then you have the 3Cl minus. Okay, this will be the equation. Okay, let me just balance it out. 3, and then you have 6 here. 3 will be placed here. Okay, furthermore, if we need to make the acidic solution, now we have just made the complex ion. Now this complex ion will do what? It will further react with water to form this solution. This complex ion that we have made will further react with water to form another complex ion that will be something like this: Al H2O. Now it is 5. Okay, and this is OH. Along with that, then you have now 2 plus, and the hydrogen. Okay, water has H and OH ions, so one water was broken down and its H was taken and added to this water, so it became H3O plus. That H plus ions made the solution acidic. Clear? and also it has a reversible sign. Okay, not the straight sign, because a reversible reaction the ions will be forming and broken down at the same time. pH will be now 3. Okay, clear? Then you have silicon. Silicon undergoes complete hydrolysis. Okay, these were, the partially hydrolysis. So it will just go in a complete hydrolysis to form strongly acidic solution. And white fumes of HCl again formed. Now the equation will be SiCl4, because I think, sorry, liquid, yeah, H2O, liquid, and it forms SiO2 and HCl. Okay, this is quite simple. Okay, then pH will be, if we have said strongly acidic, it means pH 2. Then we finally have phosphorus. Three and 4. So phosphorus 3, sorry, I have written oxides, sorry, PCl. So phosphorus 3 chloride will be react violently or to give a strongly acidic solution again. Strong acidic solution, and it will be something like, the equation is quite simple. You have PCl3, that was a liquid, and water to give it will be like H3PO, phosphorus acid, and again fumes of HCl gas. pH will be strongly acidic, which means pH is 2, and for phosphorus PCl5, that was phosphorus 5 chloride. So it sublimes at 163. Okay, it is a off-white solid, but it sublimes at 163 degree Celsius to give PCl3, and then it, I will just write an equation. sublimes at 163 degrees Celsius to give PCl3 and Cl2. Equation is like this. Sorry, solid, reversible, and it gives PCl3 liquid and Cl2 gas. Okay, that is how it forms PCl3. Then PCl3 reacts with water to form the phosphorus acid. And apart from that, if we want to react it, okay, if we want to react PCl5 with water, it reacts again violently. Same observation will be there. Okay, but if you want to react PCl5 with water, it will react same as PCl3, but the only difference will be the product that will form H3PO4 and HCl. Yes, these two will have same pH of 2. So acidity we can see of chloride increases across the period. Okay, because the nature of ionic chlorides are changing from nature of ionic to covalent. That is why the acidity of chlorides is increasing across the period. Clear? So this was the whole the chapter. Okay, we have completed chapter. Then in next class we will do some questions, and then we'll move on to the stoichiometry chapter. Okay, bye. Yeah, okay. Good evening, man. Hmm. 6 p.m. like the one we did today. Okay, okay. We can also do like we can do the class, you know, before the Saturday as well. We can shift the class day as well. That is also possible. Yeah, yeah, yeah. Yeah, we can do Thursday. Okay. Either, okay, if we can do at 1 p.m. or do you want a little bit late? Yeah, like at 4:30. Yeah, yeah. We can do that. So if it is not possible on Thursday, so then we'll do on Saturday at 6 p.m. Okay. So now, uh, yeah, yeah, yes. Okay, okay, thank you. Um, memorize in the way, yeah, memorize in a way that, conceptually. First, you have to understand the concept, then you have, but if you are practicing enough, by writing, then the equation get memorized by yourself. Okay, in your brain they get memorized. So I told her to, even memorize some balancings, because in paper she won't be having any time to balance these type of equations. Okay, that will waste a lot of time. If she is good in balancing the equations, then well and good. But some have a different type of products that are formed in these equations, that are if we assume that this will form, yeah, the complex ions are being formed. So for that she has some of the equations she have to practice, and get to know the products and the balancing that will be formed. Okay, okay, bye, good night.